All right. So yeah. So let me go through your answers. Has anybody else attempted this one? I could not. Could you can you paste your answer again if you have typed earlier? Yeah, this the one. So here. So the mapper is key and word. Okay. Key. So key tab word and the value is this. And first reducer is key and next word aggregated value and second reducer is so there can be only one reducer, right? Okay, good, good. So let me explain what I have understood. So in this, what you're trying to do is you are creating a composite key of word and next word as the word and the next word as the key, and value is next word dash one. Okay. Now in the reducer, the word and next word composition is going to give us this. Alright, so how many times the next word has occurred after this you can compute. Good. And once we have done that, we know that which one is more frequent. And under reducer, the key is so your approach is correct, just that in reducer the key would be whatever key you have specified in the mapper actually. Okay. All right. In reducer 2, next word and descending value of oh, okay. Okay, this is the output of the reducer. Okay. So reducer 1 will give out word, all right, and next word. So what is the key? This whole is the value because reducer will give out. Okay. So next word and aggregated value is the value and the word is this thing. Now again you pass through the map reduce phase where there is no map reducer, no mapper, but there is only a reducer. Okay. Okay. And next word. Okay, that is good. That is good. All right. All right. This is good. Anybody else? Okay. So yeah, this approach is correct. Yeah, we can change the key in the next. So basically, he has created three phases of MapReduce. MapReduce 1, okay, where the mapper is creating the. This is our mapper for MapReduce 1, and this is the reducer for the first phase, and this is okay. So what will happen here is it will basically bring all the or tuples, all the pairs of the words together. So if there are happy birthday hundreds of times, so happy birthday will become the key and the value will be birthday 1, all right, and that way we will exactly know that happy birthday has occurred how many times. Okay, so basically it's finding the frequencies of phrase of two words. Okay, finding the frequency of two words phrase in the whole text. Okay, so basically first word, second words, all such combinations is trying we are trying to find out the frequencies of such. This will tell us which two words come together in that order. Okay, come together frequently. And once we have figured that out, we have solved our problem. So basically, it's a word count problem. Good job. Anybody else? Okay. So that was Kalyan's approach. Now let me have a look at Srinivas's approach also. So yeah, Srinivas's approach is split entire data map into first word. Yeah, correct. That's a similar approach. Good, 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 good. That's a good approach. All right. So, all right. So let's have a look at one of the approaches which I'm going to talk about. So this is the most rudimentary, most rudimentary approach. In this approach, so this is our text, and what Mapper did was it broken down a key and value as. All right. I think Manish also has something. Let me also discuss that part. So first job, the mapper is to just clean up the HTML and grab the text. Okay. So this one mapper. So it will be just a mapper, right? It's just a mapper. The first one is just a mapper. Okay, without even sorting. So we can disable the sorting as we had discussed in the last session. Second job is to get the result produced by first job, and here, all right. So this is working fine. I'm just wondering that it might, will it reboot again suddenly? Second job is to get the results produced by first job, add a duplicate word. Example, no big data is okay. Will get converted into no data is new line. Okay, is a leader in training. Perfect, perfect. What he is trying to say is it will get converted into something like this. Perfect, perfect. So yeah, awesome, awesome. So yes, so this is one approach, and other approach is what Srinivas is telling. So in this approach, what he has done is he has taken this text, okay, and first first key is this, and value is. Then in the next line, is the first value, first key, and the leader is the value. Okay, so no big data is the key, and this is the value. This is the key. This is the value. This way, what will happen is all the words that follow no big data will come together. Similarly, all the words that follow is will come together. Similar in this one, all the words that follow lead and so on. Okay, this way we are bringing all the words that follow a particular words together. Okay, basically that particular word is our key, and for each key, all the words that follow it in the huge text that will come together as per this logic. All right, and same thing I'm also trying to do it here. Okay. So how are you, Ram, happy? Happy birthday to you, and you happy, happy new. And in case of year, we'll have to skip it. Note that in this approach, what's happening is we have got how many lines? Four lines. First line, second line, third line, fourth line. And our mapper will get the input line by line from the Hadoop. Okay. Our mapper will get the input line by line. Okay. And then it will process it line by line. And then the result will go to the reducer. So there are multiple challenges in this. Do you see any problem with this? Anyone? This approach, so is the approach clear to all of you? We basically broke down into pair of words which are coming together or which are following each other, and then we are trying to find out, in the reducer we will find all the, so if there are multiple words that follow some word, for example birthday and new are following happy. So in the reducer what will happen is it'll look like this. Okay. Here this data will get sorted first internally. So it will get sorted, and then this will be get grouped. All right. So there is nothing else to group. Yeah. Then under this, if there are, it'll do the computation. And so Manish is saying yes, you miss some of the keys like Ram as you're missing. Perfect. So here, since we are only given one line at a time, since we are given one line at a time by Hadoop, we are not able to pair you and Ram. Okay. Also, we should not be pairing these. This we can avoid anyway because we are given the whole line. We can figure this out. Okay. So the meaning is that instead of processing line by line, ideally we should be processing it either sentence by sentence or e- or paragraph by paragraph. Okay. So correct, Manish. Now we have the key is same. Uh, okay. Will not be able to bring matching values together. Can you explain, Kalyan, a little bit more? I'm not able to understand that. The keys are same. Yeah. Yes. Correct. So birthday and new will come together as the values. Correct. So yes, Mohan's point is that we are we assuming that punctuations are removed. So removing punctuation is itself a difficult thing. So let's assume for this problem that we have removed punctuation in our MapReduce itself. And also we have taken care of cases. Correct, correct. So Kalyan's point is that if there are multiple in this problem as we have shown, happy birthday, multiple happy birthday and happy new year, we have to ensure that they are coming together. That is correct. So the way we will work here is all the words will be aggregated by the first words. So happy, birthday, new, and so on. Now, the computation of the frequency of happy and new will be done by the reducer. Okay. So Hadoop will make sure the MapReduce part component of Hadoop will make sure that all the words that follow happy will come together, and in reducer you will have to do the frequency analysis and then figure out only the top 5 words. Now question is, what are the challenges do you see? One challenge, big challenge we found. Correct. So yeah, Srinivas's question point is reducer has to use again one more mapper like mapping. Yes. So either reducer does it everything by itself in the memory, or it can delegate further. So yeah. So those are few problems. So first is computation of frequency can be further map reduced. Okay. Yes. So in the previous approach, reducer was playing a very big role. And imagine the words like is, am, are, because after is, am, are, or any preposition, there are billions of words that will follow in humongous text. And doing the computation analysis, frequency analysis of billions of words in the reducer is itself such a big headache. And if you remember that earlier we discussed that for each key, all the values are bound to be on the same machine. All the values for a key, all the values for a key are bound to be collected on a single reducer. No many how many reducers are there, no matter how many reducers are there, still all the keys, all the values for a key will be gathered on one node. Alright? Good, good. So we have covered all these 3 points. So the answer to yeah. So answer to your questions, Srinivas. So is the approach which was given by Kalyan, and I think you also. In this, what we were doing is, in that approach, what we were doing, instead of forming key based on these first word, second word, we will make first word and second word the pair as the key, and then find the frequency of those words. So that's one way to do it. All right. And your previous approach is correct. All right. Now, what we are going to discuss here today is that how do we avoid this kind of problems? We do not want to process line by line. We want to process it some other way. Okay? We want to process it paragraph by paragraph. We want to process sentence by sentence. How do we do that? Okay? How do we make that happen? There'll be lot of problems you will see in future which demand special treatment of input data. Like in this one, the single line which is given at a time by mapper reducer is not the right approach. we should be given one paragraph at a time or one sentence at a time. Alright, so let's just try to see what can we do about it using MapReduce. So Hadoop provides you all the customizations and all the ability to do all of this. So today we are going to get into the details of this one. Alright, quick questions. The data generated by mapper is given to reducer, and so this is a quick quiz. So that, yes, are you able to see the screen and read it? The question is, the data generated by mapper is given to reducer and then it is sorted and shuffled. Yes or no? Correct. Which flag? Alright, alright. That's correct. The answer is no. Okay, got it, Srinivas. So, yes. And so, alright. I think Kalyan means that the flag which says that should we sort a data or should we have the reducer or not. That flag. Yes, correct. So by default, the grouping and sorting is on. We can turn it off when there is no reducer. All right, good, good. So the answer is no. The output of mapper is first shuffled or sorted and shuffled, you can say, and then reducers are called by Hadoop. Okay, so next question is, the mapper can only generate a single key value pair for an input value. Anyone can help me with this? The mapper can generate only one key value pair for one input value, input text or input line or input whatever. Correct. The answer is false, no, or yeah. So mapper can generate as many key value pair as it wants for an input. If you remember, because the important part here is those people who have not gone through MapReduce and who are just trying to figure out the meaning of mapper, they will generally say it is one-to-one mapping. Okay, as in that was a traditional definition of mapping. You run a earlier in traditional terms, like in Perl, there was this function called map, which you apply, which basically applies your mapper code onto an array. What does it mean? It will execute your function on each element of the array. It will take the value from each index, give it to your function as the argument, and whatever is the result of returned by your function will be stored in another array. So that was one-to-one mapping, and that's where lots of people get confused who have not worked on MapReduce per se. All right, all right. So good, good. So all of us are on the same page. Now, next question to you is: a mapper always Alright, if in case inside the mapper you want to load the data from HDFS, you can do that too. Right now, in our example, before launching our MapReduce job, we are providing the input folder and input file, correct? What if our HDFS, our map and reduce logic, we want to access the HDFS? In those cases, you can use this class called file system class, and I can show you quickly that it does really. Srinivas, for which one? This particular case? Yes, I can give you. You mean why would? All right. So you can see that we have file system, and we can say Hadoop file. Note that this has to come from Hadoop. Okay. Do not do not try to. This is JavaNet, and this is something like HDFS, and say user slash student slash sgiri slash some file dot txt, like this. So here you can basically, all right, yeah, this is good enough. All right, so we can say context dot get configuration. Okay, so here you can provide context dot get configuration, and then we can start loading the file. Okay, we can say copy from local and whatnot, although these are static. Okay, so you can say get block locations. Okay, you can do anything what you want to do actually. All right. So yeah, conf object is from context, and then you can read the file and do whatever you want. All right. And not only you can access a file, you can also, using the same file system object, you can also create folder onto the system. You can delete from here, so you can basically manipulate the whole HDFS using file system object. Okay. All right. So yeah, coming back to the question of Srinivas, who is saying that can you give a real example? Let me try to give a real example. Okay. Now let's talk about a scenario where basically from one mapper we are trying to read some data from HDFS. So say inside the driver, or how should I think about yeah, let me think of a little bit more clever ways of explaining. All right, all right. So in the map driver, for example, In the map driver itself, we are trying to figure out that whether we should be running multiple reducer or a single reducer, or what should we be doing. Okay, in those cases we can quickly examine the HDFS input file from here, from the step driver, that how big is our input file. Okay, and once we have figured that out, that how big is our input file, we can create that many number of reducer in the driver. Alright, so those are the few use cases, and there are many such use cases. Okay, the other thing is, for there are some zip compression formats which are which are okay to split the file, which can happen on partial data. One such input type is LJADO. LJADO compression can be applied on chunks of the data. LJADO compression is fairly tolerant to the split of data. So if you remember correctly, that when we so I'm sorry. So have you ever used zip file and have splitted a zip file and tried to unzip individual files? And you cannot generally unzip individual parts of data in case of normal zip, correct? But in case of our HDFS, where we are trying to store our data into HDFS, we would require a compression such that the data individually, also each part of the compressed data can be uncompressed easily. In those cases, you could use gzip splittable or Hadoop Aljado. Both of these projects are for those cases when you want to store your data in a compressed format and you want to uncompress each block independently. Alright. So this is general overview of classes. So the entry point of the whole game is input format. A input format basically gives out two things: get split and create recorder. If you want to create your custom input split, if you realize that none of the existing solutions are doing a good job and you want to create your own input format, then probably you will be using MapReduce input splits. Okay, you'll be using input format and input split. So the first thing which you will implement is you will basically extend input format class and provide your record reader, and then you will implement your record reader. And generally you can also extend input split class. The by default input split class has to provide length and the location of the data. Okay, you can implement your own also by extending input split, right? Okay, Srinivas's question is that which input splits are useful for video file. Okay, so my first question is that what do you want to do with the video file? Okay, so the have a look at the sequence file. Most of the binary files, wherever you want to churn the whole file in one shot, the fixed format or the file sequence input format is the one which will come to use. Okay, in most of these. Storing video in YouTube while running online. Okay, okay. In those cases, a better way would be you just store the no it's like a binary file. Okay, you store it just like that. But You write your own reader, okay? Because it's a binary file and you want to read one block at a time. You will have to write an API to retrieve the data and then present to the web interface. Okay, so you will not have to create MapReduce for this. You will not have to create basically input splits. Here what you need to create is your class which can read from HDFS a video file and then display it to the web interface. Make sense? To analyze the frequency of common words used in the videos file. Okay, okay, that's interesting. That's interesting. So the question here is we will have to create splittable video files, which means that if we are given a handle to the video file, the parts of it, we should be able to play it separately. Okay, I need to find that out, that what will be the, so basically Baswara's objective is to be able to churn the video file one part at a time, okay, using MapReduce. In those cases we'll have to figure out how can we split our video file such that each part is each part of this video file is basically individually playable. Okay, so we need to find that out. Correct. And similar is case with the yeah, that's very good use case. Thank you, Srinivas. So yeah, that's an interesting part. So imagine that you're looking for somebody's face and you have got say 20 GB or 30 GB file. Now Now imagine that churning some 10 MB of such video to match a particular photo takes around 20 seconds. Now, if you try to run, this against what we are trying to do, for the full file, it is going to take a long time. So a better strategy would be that we split the video files such that each individual parts can play parallelly. So one node can run the video from 1 to 10 minute, the second can run from 10 to 20 and so on independently parallelly. So how can we split the video file? Which input split we should use in such case is something I need to figure out. I haven't used it yet, but that's a very good thing to do. Okay. And there are lots of video analytics use case. Like for example, the football match. People have tried to do a lot of analytics on top of football match. All right. So we will look into the video analytics, video how to split that maybe tomorrow. And we were where we were. Yeah. So you can extend the input splits, and in the input split you can basically customize it. I have written an example. You should, if you have time and are inclined, you should go through the custom input splitter. The idea is extremely simple. It's just that to implement it, it's difficult. So imagine that there are, let me just take it, and I hope you will stay with me for a few more minutes. Okay, just a second. So yeah. Alright, now you can see that this is our file. Okay, now on this is on first node. This is our first node number 1. This is our node number 2, and this is our node number 3. Correct? Which means on these 3 nodes, the processing of each input split will start parallelly. Okay, so the first node, let's say that it starts from here. in the beginning, second starts from here, and third starts from here. So all these three nodes are trying to read these three different blocks of the same file parallelly. Okay? Now what would happen is, in these logic of input splitter, the input format, or you can say create this you can say here, the create record reader, the create record reader does a lot of, because create record reader is being executed here, here, or here. The record reader is trying to create records out of this block data. So, and it's the same logic being executed parallelly on three different machines. So what does it do exactly? So on each node the logic will be like this: keep on skipping the data, keep on skipping the data, either either you did not start from the beginning of the file. In case you start from the beginning of the file, do not skip the data. Second, if you did not start from the beginning of the file, that means you are somewhere in the midway, which means you might be in the second block, second one. Okay? If you hit the beginning of the file, that means you are on the first block. If you are on the second block, which means you did not start the first byte you read, you realize that it was not from the beginning of the file. Okay? That means you are on the second block, which means you will have to keep skipping the data. You'll have to keep skipping the data unless you hit a boundary. Boundary means, in our normal case, boundary means /n. The moment it hits the new line, it will stop skipping the data, and then it will start reading the data. And same case is happening on the third block. Exact same logic, that it will keep on skipping the ninth block unless it hits the boundary. Boundary is new line. Okay? So all 1 2 3, everywhere your same logic is running, and your logic says, if your location is not 0, okay, keep skipping unless you hit a boundary. Okay, that's the logic. And similarly, you can also create your own input splitter saying keep on reading the data unless something happens, or keep on skipping the data unless something happens. All right, so that way you can basically create your own input splitter. All right. Now, how does node identify what is the starting of the file or not? So the file seek pointer gives you the location of the character. All right. That could tell you clearly that you can, the project which I have given you in this session, if you go to my courses and see this today's session, session number 5, you will see all of these details over there. All right. Now in this itself, here, I have written a custom reader here. I defined something called my input format, and then which extends some other input format, not directly input format. This guy might be extending input format. So text input format might be extending input format, and so on. Now in this I have said create record and return this one. This is what I have created here, this one. Now in this we keep on in initialize, we keep on skipping the data. See, skip first line true. We keep on skipping until we hit a boundary. You should look at this detail, this code in detail, to understand how does it really work. Okay. So here you can also see that split.get start. If its start is not equal to 0, which means we are not in the beginning of the line. All right. That answers your question. All right. So have a look at this code if you get time, and then we will again discuss few more things. Okay. Hope everybody is clear about single reducer. This diagram is clear to everyone? Is this diagram clear to everyone? All right, great, great. And this one. So now you see this input split. What does it mean? This is input split, you see? So instead of talking about blocks, we were actually dealing with input split from earlier. I just kept on avoiding it so far. Okay. So on input split, we create a single instance of the map. Then for each record, we run map function. Map function gives out key value pairs. Those get collected here. Then they are taken to the reducers where they are merged together. And then on each key we run the reduce function on all the values. All right. Then we see you tomorrow and have a good day. I know I have run 9 minutes more. Okay. All right. Thank you, Srinivas. Thank you very much. And yeah, if you guys write a blog or something, you let me know. You can write blog for us, and you know, we are looking for people who can write a blog. Okay. Maybe somebody who can basically even summarize this discussion on a blog. It will be great. So let me know if you're interested. All right, see you tomorrow at the same time. All right, bye bye. Have a good day. All right, so let me just end the meeting. Bye bye. See you tomorrow.